The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. So today we're going to take a look at section 6.7. Are there any questions before we get started? I'll take that as a no. All right.
No.
Okay, great. So section 6.7. We're going to talk about something called the zero factor property today. Zero factor. Oops. Property. Basically, it says this. If A times B equals 0, then either A equals 0 or, can't write today, or B equals 0, or both A and B equal 0. Okay? So if you have a product of two quantities and the result is 0, at least one of the factors, A or B, or maybe both of them, have to be 0. How are we going to use this? Well, we're going to use this along with factoring to solve second-degree equations. Let's take, for instance, the following situation. X plus 2 times x minus 3 equals 0. Well, this is in the form of A times B equals 0. So that means that either A equals 0 or B equals 0 or both. Okay so far? All right.
Yeah.
So now let's solve each of these first degree equations. X plus 2 equals 0. If we subtract 2 from both sides, we get x equals -2. X minus 3 equals 0. If we add 3 to both sides of the equation, we get x equals 3. So now we have two solutions to a second degree equation. Let's check our work. If we take this and we put it right there, if x is -2, -2 plus 2 is 0. 0 times anything is 0, so it checks. If we take this solution and we put it in there, x is 3, 3 minus 3 is 0, anything times 0 is 0, so that solution checks. So we get two solutions to what is a second degree equation. Any questions about that example?
No, thank you.
Let's say we've got this. 5x times 5x plus 7 equals 0. So this again is in that form, A times B equals 0. So A equals 0, B equals 0. So basically what we're doing is we're taking each factor that contains a variable and setting it equal to 0. And then coming back and solving each of these first degree equations. 5x equals 0, divide both sides by 5, x equals 0. 5x plus 7 equals 0, subtract 7 from both sides, 5x equals -7, divide both sides by 5, x equals -7/5. Okay, let's check our work. Well, if x is 0, 5 times 0 is 0, 0 times anything is 0, so that checks. If x is -7/5, if we put that in here, 5 times -7/5 would be -7. -7 plus 7 is 0. Anything times 0 is 0, and it checks. All righty. Let's say we've got this. N times n plus 1 times n minus 6 equals 0. Well, now we have a third degree equation. We'll take each factor that contains a variable and set it equal to 0. So n equals 0, n plus 1 equals 0, n minus 6 equals 0. If n equals 0, well then n equals 0, right? If n plus 1 equals 0, subtracting 1 from both sides of the equation, we get n equals -1. If n minus 6 equals 0, adding 6 to both sides of the equation, we get n equals 6. So we have 3 solutions to a third degree equation. And a fourth degree equation would have 4 solutions, and a fifth, et cetera, et cetera. All right. Now, what if we have this situation? X squared plus 7x plus 6 equals 0. So without the equals 0, this would be a trinomial, a polynomial in standard form. With it set equal to 0, it's in standard form of a second degree equation. What we're going to do now is take the left side of the equation and factor it using all of the tools we've been discussing thus far in this chapter. So we've got an x and an x. Let's see, a product that's 6 and a sum that's 7, 6, and 1. So plus 6, plus 1. So I've got it factored correctly, hopefully. So then I'm going to take each factor that contains a variable, set it equal to 0, and solve it. So x plus 6 equals 0, subtract 6 from both sides of the equation, x equals -6. X plus 1 equals 0, subtract 1 from both sides of the equation, x equals -1. Well, let's check our work. Let's take x equals -6, and we'll plug it back into the original equation, -6 squared plus 7 times -6 plus 6 equals 0. So I'm plugging this in here. -6, the quantity squared, is 36. 7 times -6 is -42 plus 6. We could add these in any order. 36 plus 36 is 42, plus -42 is 0. 0 equals 0. It checks. Let's take this second solution and check it out. -1, so we get -1, the quantity squared, plus 7 times -1, plus 6 is 0. -1, the quantity squared is 1. 1 plus -7 plus 6 equals 0. 0. 1 plus 6 is 7, plus -6, -7, 0 equals 0. So this one also checks. So a second degree equation has 2 solutions. Any questions about that example? All right, let's take a look at this example. X squared minus 36 equals 0. This is a second degree equation. It's in standard form. It's set equal to 0. On the left side of the equation, I believe we have the difference of 2 squares. So factoring it, we get x plus 6 times x minus 6 equals 0. Take each factor that contains a variable, set it equal to 0, and then solve that first degree equation. X plus 6 equals 0, subtract 6 from both sides, x equals -6. X minus 6 equals 0, add 6 to both sides, x equals +6. So there are the 2 possible solutions. Let's check our work. Let's take this one and plug it in. We get -6, the quantity squared, minus 36 equals 0. Well, -6, the quantity squared is 36, and 36 minus 6 equals 0. 0 equals 0, so it checks. Let's take this one. X is 6. 6 squared minus 36 equals 0. 6 squared is 36. 36 minus 36 is 0. 0 equals 0. Again, second degree equation, 2 solutions. All righty. You doing okay? Am I going too fast?
That's good.
We're good? Okay.
Yes.
Let's say I've got this one. X squared equals 5x. Well, this is a second degree equation because it has an exponent of a 2 on the variable as the highest exponent, but it's not in standard form. So let's move the 5x over. So we've got x squared minus 5x equals 0. A common mistake that students make with this is they see a binomial and they immediately think, oh, difference of two squares. And then they look at it and they go, but it's not the difference of two squares. So they go, oh, it's prime or it doesn't factor. But before that, you would take out the greatest common factor. And that's all you can do. So now it's factored completely. Take each factor that contains a variable and set it equal to 0. Well, if x equals 0, x equals 0, right?
Mm-hmm.
X minus 5 equals 0. Add 5 to both sides, you'd get x equals 5. So let's check both answers. If x is 0, we'd get 0 squared equals 5 times 0. 0 equals 0. That one checks. If x is 5, we get 5 squared equals 5 times 5. 25 equals 25, and that one checks. Second degree equation, 2 solutions. Bada boom, bada bing. All righty. Let's see here. How about this one? 3x squared plus 14x equals -8. This is a second degree equation, but again, it's not in standard form. So let's add 8 to both sides of the equation. 3x squared plus 14x plus 8 equals 0. Notice I moved the 8 over because I want my leading coefficient to be positive. If I move these two terms over there, I'd have -3x squared as my leading term, and that's not as fun, right? Okay. Not as easy to deal with. So now I have a second degree equation in standard form. The left side is a trinomial. There's no greatest common factor. It's not a perfect square. It doesn't have a leading coefficient of 1, so I need to factor it either using grouping or trial and check. Do you have a preference?
Grouping.
Grouping, okay. So A is, that's supposed to be an A. It's a rather sad looking A. A is 3, B is 14, C is 8. The product is 3 times 8, which is 24. The sum is B, which is 14. How about 12 and 2? 12 times 2 is 24. 12 plus 2 is 14. So now we have 3x squared plus 12x plus 2x plus 8 equals 0. So I'm going to use grouping on the left side of the equation. I'm going to split those 4 terms into 2 groups of 2 terms. The greatest common factor of the first 2 terms is 3x. The leftovers are x plus 4. The leftovers of the second 2 terms are x plus 4, and a plus 2 comes outside. So then I've got x plus 4 times 3x plus 2 equals 0. So I've got it factored equal to 0. So it's in the form of a times b equals 0. Take each factor that contains a variable and set it equal to 0. And then solve it. So x plus 4 equals 0. Subtract 4 from both sides. We get x equals -4. 3x plus 2 equals 0. Subtract 2 from both sides. 3x equals -2. Divide both sides by 3. X equals -2/3. So we've got x is -4. X is -2/3. Let's check our work. Let's take x equals -4 and put it into the original equation. 3 times -4 squared plus 14 times -4 equals -8. Order of operations, we do the exponent first. 3 times -4 times -4 is 16. 3 times 16 is 48. Plus, let's see, what do we get? -56. And 48 plus -56 is -8. -8 equals -8, so it checks. Okay, then I've got x is -2/3. I'm going to go to the next page, so I have some room to check that. So let's see, we've got 3x squared plus 14x equals -8. X is -2/3. Have I got that right? Yeah. Okay, so 3 times -2/3 squared plus 14 times -2/3 equals -8. Sometimes it's more work to check your work than it is to get the answer in the first place. But I don't know about you. If an engineer is designing a building that I'm going to go in, I want to make sure they check their work very carefully. All right, so what do we have here? We've got 3 times -2/3 times -2/3 would be 4/9. I could reduce that down to 4/3. And then I've got plus -28/3. So plus -28/3 equals -8. Well, 4 plus -28 is -24. So -24/3 equals -8. And -24/3 is -8. -8 equals -8. Check, check, check. It all works. Okay. What about this one? 5m times 5m plus 8 equals -16. Now, some people might see this and start celebrating and go, woohoo, it's already factored on the left-hand side. I don't have to do all that work. Oh dear. The problem is it's not set equal to 0. So we can't just take 5x and set it equal to 0. We can't take 5x and set it equal to -16. We got to multiply the whole thing out, move the -16 over, and then pull it apart again because it's got to be set equal to 0. So this is 25m squared plus 40m equals -16. I'm going to add 16 to both sides. 25m squared plus 40m plus 16 equals 0. Now I'm going to factor it, but it has to be set equal to 0 before you can do that and get anywhere with it. Well, you know what? I think this is a perfect square. Let's see, 5m and 4, 5m and 4 plus and plus. Yeah, it is. How about that? So I'm going to take each factor and set it equal to 0 and solve it. 5m plus 4, subtract 4 from both sides. 5m equals -4. Divide both sides by 5. M equals -4/5. Now, since this factor is the same, or this factor is the same as that factor, I'm going to get the same answer twice. Okay. And what the book does is they'll say M equals -4/5, and they'll say repeated. Okay. So we still get 2 solutions, but they're the same solution twice. Any questions about that? All righty. Let's take a look at this one. X cubed minus 7x squared plus 10x equals 0. This is a 3rd degree equation. It's in standard form. It's in descending powers of the variable, and it's set equal to 0. So on the left side of the equation, the trinomial, the first thing I can do is take out a greatest common factor. Then the trinomial that's left over has a leading coefficient of a 1, so I can split it apart. Product is 10, sum is -7, -5, oops. So -5 and -2. Take each factor that contains a variable and set it equal to 0 and solve each first degree equation. Well, if x equals 0, then x equals 0. X minus 5 equals 0. Add 5 to both sides of the equation. X equals 5. X minus 2 equals 0. Add 2 to both sides of the equation. X equals 2. Let's check our work. If x is 0, plugging it in here, we'd get 0 cubed minus 7 times 0 squared plus 10 times 0 equals 0. Well, 0 cubed is 0. 0 squared is 0 times 7 is 0. So 0 minus 0 plus 10 times 0 is 0. 0 minus 0 is 0 plus 0 is 0. 0 equals 0. That's a lot of nothing, isn't it? Okay. How about 5? If x is 5, 5 cubed minus 7 times 5 squared plus 10 times 5 equals 0. 5 cubed. 5 times 5 is 25, times 5 is 125, minus 7 times 5 squared, which is 25, plus 10 times 5, which is 50. 125 minus, let's see. If you have 7 quarters, you got $1.75 or 175 cents. 125 plus 50 is 175 minus 175, 0 equals 0. It checks. Okay. And let's go back and check the x equals 2. We'll do that on the next page. X cubed minus 7x squared, 10, let's see what do we got here, plus 10x equals 0. And then x equals 2. 2 cubed minus 7 times 2 squared plus 10 times 2 equals 0. 2 cubed is 8 minus 7 times 4 plus 20. 28 minus 28, 0 equals 0. Third degree equation, 3 solutions. Any questions about that? Okay. What about this one? 9y squared equals 64. Well, that's a second degree equation, but it's not in standard form. So let's put it in standard form by moving everything to one side of the equation, set equal to 0 on the other. But this is the difference of 2 squares, I do believe. 3y, the quantity squared, minus 8, the quantity squared. So our factors are 3y plus 8, 3y minus 8 equals 0. Take each factor that contains a variable and set it equal to 0, and then solve each first degree equation. 3x plus 8 equals 0. Subtract 8 from both sides. Oh, excuse me, 3y. We're dealing with y. 3y equals -8. Divide by 3. Y equals -8 thirds. 3y minus 8 equals 0. Add 8 to both sides. 3y equals 8. Divide both sides by 3. Y equals +8 thirds. Okay, let's check our work. If if y is -8 thirds, 9 times -8 thirds squared equals 64. 9 times, let's see, -8 times -8 is +64. Over 3 times 3 is 9. The 9's reduced down to 1 over 1, 64 equals 64. If y is +8 thirds, I get the same thing, don't I? 64 equals 64, so it checks. Okay, now, what about, let's see, where did it go? There it is. What about this one? 2m squared minus 8m equals 2m minus 12. So this is a second degree equation, but it's not in standard form. I'm going to move everything to the left side so that my leading coefficient is still positive. So I'm going to subtract 2m from both sides, and I'm going to add 12 to both sides. So I get 2m squared minus 10m plus 12 equals 0. So now my second degree equation is in standard form. I'm going to factor the left-hand side. Well, there's a greatest common factor of a 2, so I'll take that out. Then I've got a trinomial with a leading coefficient of a 1. Let's see, the product is 6 and the sum is -5, -3, and -2, I believe. Yeah. Now, be careful. Don't do this. 2 does not equal 0. This is what I've said all along, but it didn't really matter until now. This is what I've said. Take each factor that contains a variable and set it equal to 0. 2 is not a variable, okay? Now, you might say, well, but do you just ignore it? Well, here's what we could do. If we wanted to go to the trouble, we could say, you know what? Let's divide both sides of this equation by 2. Well, that would reduce out and we'd have that. So then we take each factor that contains a variable, set it equal to 0 and solve it. But because we can do that, what we can do instead is just take each factor that contains a variable, set it equal to 0. We can ignore the 2 because we could in fact divide both sides by it and get rid of it, okay? But only because it's a constant, not a variable. Add 3 to both sides, m equals 3. Add 2 to both sides, m equals 2. All righty. Oh, let's see here. How about this one? X cubed plus 7x squared equals x squared minus 9x. This is a third degree equation because of the x cubed term, so we're going to have 3 solutions. First of all, I'm going to put everything on one side of the equation and set it equal to 0 on the other side. So I've got x cubed plus 6x squared plus 9x equals 0. On the left side of the equation, I could factor out the greatest common factor, which is an x. Then I could take the trinomial, which suspiciously looks like a perfect square, and it is. Then I could take each factor that contains a variable, set it equal to 0 and solve it. Well, if x equals 0, x equals 0. If x plus 3 equals 0, subtract 3 from both sides, x equals 3, same equation, same solution. So we've got 0 and 3 repeated. Now, as far as how to list them in WebAssign, I would look and see, probably you'd want to write them each individually. I don't know. You could try the repeated thing and see what works in the homework first, but test it out before you run with it to the bank or wherever. Okay. Well, oh, one more thing. There's always one more thing. It says factor the expression in part A and solve the equation in part B. A common mistake that students make is they take an expression, okay, and they factor it. Let's see, this is going to be that. But then they set it equal to 0 and solve it. But it's not an equation, so don't turn it into an equation. Okay, you can't say x is -7 and x is 3 because this is not set equal to 0, so you can't make any assumptions other than you can factor it. Okay, now part B is an equation, so that when you factor it, set equal to 0, there you would come back and solve it. But I've seen students take this on a test, set it equal to 0 and solve it when it's not an equation. I've seen students take this and just do that and stop, and they don't solve it. Okay. This chapter, most of the problems could boil down to one of two words, either factor or solve. If you're solving it, typically you're factoring it and then solving it. But if you're just factoring it, it's not an equation. So be careful of that. All right, that's all I have for you today. So for this evening, section 6.7, I'll be back at 1:15 with an office hour should you have need of me. I'm going to go ahead and stop the recording.